The broadcast is now starting. All attendees are in listen-only mode.
Afternoon, or good morning, good evening, depending on where you are. On behalf of RBCS and software test professionals, welcome to our webinar today. The webinar is on test strategies from around the world. I am Rex Black. Excuse me, a sip of tea in there. I'm president of RBCS. We are a worldwide testing and quality assurance firm. We serve clients, small clients, big clients, have done so since 1994. We're a pioneer and leader in quality hardware and software testing. Our offices are in the United States, but we have partners around the world. In fact, I just got back last night from a very pleasant trip to Moscow. We deliver insight and confidence to our clients. We help them get quality software and hardware products to market on time with a measurable return on investment and high value for their customers. We have a team of international consultants who deliver customized training, consulting, and outsourcing services for companies looking to improve their testing and quality assurance practices. We have helped hundreds of companies reduce development and support costs while assuring the best quality products are delivered to customers. I am the author of Pragmatic Software Testing, Advanced Software Testing Volumes 1, 2, and 3, Foundations of Software Testing, Critical Testing Processes, Managing the Testing Process, and Fundamentos de Pruebas de Software, which is the first book on the ISTQB certification in Spanish and the first book in any language that was aligned with the 2011 Foundation syllabus. I am also the author of 2 upcoming ebooks. One of them is called Testing Metrics, Measuring Product, Process, and Project Quality. That should be out this month. The other is Improving the Testing Process, a value-based approach to assessing and enhancing testing maturity. I have a degree in computer science and engineering from UCLA, and I'm past president of the ISTQB and the ASTQB. We are presenting this webinar in partnership with software test professionals. If you haven't visited their website, check it out. It's www.softwaretestpro.com. That's Software Test Pro, all one word. Attending today's webinar may earn you credit for QAI and ASQ recertification. Check with QAI or ASQ to determine how to qualify. It typically involves saving the attendee email that you'll receive after this webinar and submitting that as proof of attendance. Attendance at today's webinar also earns PMI PDUs. I would like to thank Rex Price for reviewing the materials for PDU status, and at the last minute, too. Rex, if you're listening, thank you very much for your immediate help with our crisis situation here. Visit www.pmi.org to claim the PDUs. You use the code TSAW100. That's PMI PDU code Tom, Sam, Adam, Warsaw 100. RBCS's provider ID is 2986. Please note that PDUs are available for live webinar attendance only. You may be audited by PMI if you claim these PDUs, and you will have to show proof of attendance using the email that you'll receive if you are attending this webinar. If you were listening to a recorded version of this, you may not claim them. By the way, we are looking for volunteers to review the materials for PDUs. So if you're interested in getting an early preview of these webinars and providing us with some helpful feedback that can improve the presentations, please send an email to info@rbcs-us.com with the subject line PMI PDU volunteer. Please note that you must be PMI certified already with a PMP certification to approve these for PDU credits. Before we get into the presentation, some housekeeping notes. If you have any questions at any time, you can submit them via your question interface webinar. Please note that I do not look at those questions until at the end because I can't balance trying to go through questions and give the presentation at the same time. So please note that your questions will be answered in order starting at the top of the hour. You don't need to ask for presentation copies. The presentation is already posted. It's at www.rbcs-us.com. You go to the basic library, navigate to the resources button in the upper middle of the screen, and then the library will drop, or a menu will drop down. You navigate that menu to the basic library. You'll find a PDF of these slides at the bottom of that page. You don't need to ask about how to register for the free e-learning. By attending this webinar, you were automatically registered. Make sure to check your email over the next couple of days and watch the spam filter so that the notification doesn't get lost. If you're having problems with the audio or visual elements of the webinar, you can do a few things. One is go to webinar support. Another is check if it's sound, check your sound settings. If you're having trouble getting to the webinar at all, or it's not working properly once you get to it, the couple of major causes for that are, one is browser incompatibility, so try another browser. Another is company firewalls, in which case you'll need to use a personal computer or personal device to access the webinar. Let's see. I hope you enjoyed this free webinar from RBCS. We do these as a service to the software testing community because at RBCS we're a not just for profit company. Now today's presentation is testing strategies from around the world. One of the most famous strategists in the world is Sun Tzu. As a Chinese warrior and scholar, his writings have really survived the test of time and remain relevant even today. So, that book, Art of War, is a commonly read book in business management curriculums. So, as a tester, you probably struggle trying to meet your testing and quality objectives, and to do that effectively, you need a strategy, a well thought out strategy. So, in this presentation, we will talk about how you can put such a strategy in place. By the way, this is a repeat presentation of this. I gave this presentation last week in New Orleans at the STP conference, which was quite a good time. Highly recommended if you looking for a conference to attend. They have one coming up in October, I believe. Okay, so terminology. What do I mean by test strategy? Well, what I mean by that is general project-independent pattern for how the testing is done. General meaning that it's applicable in a large number of situations. Project-independent meaning that I'm not talking about a test plan for a particular project. I'm talking about patterns in the kinds of things you see in test plans based on the underlying strategy that an organization is following. Now, many times organizations don't really, test organizations don't really think this through. I mean, they follow a strategy, but they're not really sure why they do things the way they do. The purpose of this is to get you to think really clearly about what your strategies are and improve your strategies by adopting some new ideas or maybe changing some of the ideas that you've got. Now, there's no blue sky or theory here. These are all strategies that are in use by test teams from around the world. Now, the thing with the strategy is that if you employ it in the right situation, it'll work. And every one of the strategies that I'm going to talk about here has worked in some situations. But if you use it in the wrong situation, it may not work as well as some of your other options, or it may not work at all. And that can happen. So you have to recognize the enablers and disablers, if you will. So let's go through some of these strategies, how you can select them, how you can recognize them, and how you can blend them together to have the best possible overall strategy for your organization. Okay, so first of the strategies, types of strategies that we tend to see with our clients around the world are the analytical test strategies, and there are two very common strategies in this category, or family, if you will. One is what's called requirements-based testing. So in requirements-based testing, you analyze the requirement specification, and based on that, you identify various test conditions. And then you develop test cases to cover those test conditions and run those test cases. Now, another analytical strategy is what's called risk-based testing. So in requirements-based testing, we analyze the requirements to identify the test conditions. In risk-based testing, we work with stakeholders to identify the risks to the quality of the system. And those risks are essentially the test conditions that we're going to cover. And then we develop tests to cover those conditions, those risk items, generally changing the extent of testing based on the level of risk perceived for the different risk items, as well as sequencing the tests when we ultimately run them based on the level of risk that the risk items have. So the trick there is that there is some, or the pattern, excuse me, is that there is some analysis that happens up front before the test execution starts, ideally during the planning and preparation stages of the project, or if you're in an iterative life cycle for during the planning period of the iteration itself, and the testing follows from that analysis. The analysis drives the testing, hence it's analytical test strategy. So, what are some of the benefits that we get out of an analytical testing strategy? One is, assuming we execute the strategy properly, we get good alignment between the testing that's done and the test basis. Now, the test basis is just simply whatever the tests are based on. So if we're doing requirements-based testing, then the test basis is the requirements. If we're doing risk-based testing, it's the risk items we identified. Now, the tests, once they're developed, if we're meticulous about this gives us another benefit. Not only are we aligned with the test basis, but we develop the tests and capture traceability of the test back to the requirements and or the risks, and then we can measure how well we've tested what we set out to test. We have measurability based on the coverage analysis via traceability. Now, another benefit of an analytical testing strategy is defect prevention. Now, this one kind of confuses people sometimes, but here's what I'm talking about. In the process of identifying risks or analyzing requirements, it's often the case that problems are found in the requirements documents, in other project characteristics, and those problems would ultimately result in defects in the code. But because the analysis happens before the code is written, by finding and removing those defects, we essentially prevent introduction of other defects into the code itself. So that's a benefit, and potentially a very significant one. Finally, there's transparency of the test coverage, which simply arises from the traceability. We've got traceability of the tests and their results back to the test basis. We can clearly establish what was covered and what hasn't been covered, and that can be done pretty much at any point in time. Now, what are some factors for success that apply for analytical strategies? Well, if you have a document-focused strategy such as requirements-based testing, obviously you would need the requirements to do that. If you're not given the requirement specification, you will not be able to analyze it, of course, a common breakdown. Now, the stakeholder-focused strategies like risk-based testing, you're not necessarily dependent on a requirement specification, but you do need the various stakeholders, project and product stakeholders, to participate in the risk analysis process. Now, what are some risks? Well, in the case of a document-focused strategy like requirements-based testing, obviously if the requirements are changing very rapidly or changing in a way which is not managed, the test team is not kept in the loop, then that causes a breakdown in terms of what's being tested and what's being built. And you tend to get a large number of false positives and false negatives that come out of that process. And of course, if the requirements are bad, the tests that come out of that will reflect that. To the extent that the requirements are wrong, to the extent that the requirements are missing elements, then the tests that come out will in that same way be flawed and missing things. And of course, if you don't have the requirements, then you're stuck in a purely requirements-based approach. Now, the stakeholder-focused approaches like risk-based testing do not have this problem because they're not dependent on the on work products produced by other people, but they are dependent on getting the stakeholders engaged in the process. Now, worth mentioning here that in the 1980s, analytical requirements-based testing was seen very much as the one true way of testing, the only real strategy for testing, and that's sort of reflected in some of the books of the time. Said, you know, this is how we work, right? This is how we do things, and there are still proponents of this out there, but I think the risk that I mentioned here about being broken, your test process is broken by the problem in a work product that's not in your control, I think has led people, well, certainly a number of our clients, to try to insulate themselves from those kind of breakdowns by using other strategies as well, such as risk-based testing. So move on to the next family of strategies, if you will, group of strategies. This is model-based strategies. Now, in a model-based strategy, we're going to have some kind of model, and the tests are going to arise from the model itself. So one example of this is in reliability testing and performance testing, we have what's called operational profiles, which is basically looking at things like the environment in which the system is going to work, kind of inputs that the system is going to be subjected to, and how the system should behave or is expected to behave under those inputs, and that determines the test. So if you think about doing performance testing of an e-commerce site, you know, you're going to have a certain host system, and you're going to have a certain number of expected customers per day, and there's going to be certain distributions to that. Like maybe the minimum and maximum loads are determined by a time of day in various major cities that are in your market. Of course, if you're worldwide, then this might be the load might be a little bit more more interesting distributions, more peaks and valleys. Of course, that varies based on the day of the week. You know, your traffic looks different on a weekday versus a weekend day. Traffic looks different based on time of year. If you're in certain kinds of business, you know, retail, you'll tend to sell a lot towards the end of the year, in November. And so those all are parts of your model of how the system is going to be loaded, and then you have expected results like response time of half a second or less, say, you know, how long it takes to move from one page to the next. This can also be done for functional tests. So you have UML, and that's a model of the system's functionality, and then that can be used to derive tests. So the key of model-based test strategy is that we create a model, and then the tests proceed from the model itself, and our coverage is determined based on the model, what it would mean to cover the model. Now, what are some benefits of a model-based approach? Your testing will be consistent with the real-world usage, how the system is actually going to be used, assuming that your model is correct. Now, I want to point out something about these benefits. Each of these strategies, as I go through, I'm going to talk about the benefits. Now, if you look at any of these benefits and you say, you know what, I don't care about that, that's not interesting to me, then that would indicate that this is a strategy that may not be useful for you in your organization. The benefits, if you want them, are available by selecting the strategy which provides the benefits. But if you don't want them, then that indicates a mismatch between the strategy and your and the world you're in. Now, what are some factors for success with model-based strategy? Well, of course, the model has to be accurate. The underlying model has to be accurate. Now, what I mean by accurate means it has to reflect what's actually going to happen. To the extent that the model is flawed, of course, your testing will be flawed, and your results will be, again, lots of false positives and false negatives. False positive being where you report a defect but the behavior is actually correct. False negative being that you miss a defect even though you actually test something. You just don't notice the defect, perhaps because the model's telling you, oh yeah, that's correct behavior. Well, it's actually not. Another thing that's a factor for success frequently with model-based strategies is the available tools. Many of these strategies involve some amount of automation, and to the extent that you have tools available, then tools that will actually support the automation of the model, then that enables success. Now, risks. Insufficient data to derive the model. You don't know enough about what's actually going to happen. That would of course result in the model being wrong. But it's also possible to have sufficient data, but then to make mistakes in the way that you analyze the data, statistical mistakes that results in the model being wrong as well. So either of those things end up creating a problem with our model. Another risk is picking the wrong tool. We have clients sometimes that tell us about how they're doing performance testing with functional test tools. Well, that's not the right tool for the job. So you need to use the right tool. And of course there has to be one available, right? There's another risk is that no appropriate tool is actually available, which would be a major problem most of the time with the model-based strategy. Another risk in a model-based strategy is a tendency to focus on the positive paths, what's supposed to work. And not do so much testing on things that are not supposed to work. The negative testing, the testing. What happens if we try this? What happens if we try that? The model, to the extent that the model predicts correct behavior, we might not test the things that would be responding to problematic situations. Now, as with the analytical strategies, there is stakeholder involvement. The stakeholder should be involved in validating the model and the way that you constructed it. That helps to mitigate the risk that the model will be wrong. Okay, the next strategy is a methodical test strategy. So in a methodical test strategy, we have a standard set of conditions that we're going to cover, right? So if you think of the analytical strategies, we analyze something, conditions follow from that. In the model-based strategy, the conditions are derived from the model. But in a methodical test strategy, we have a pre-existing set of conditions that we've defined, and those conditions will be used over and over again to do our testing. Now, where did this predetermined set of test conditions come from? Well, it can come from any number of places. You could have a quality standard like ISO 9126 that you're following. So you go through the quality standard and you look at the different characteristics and subcharacteristics that are applicable. And then based on that, you say, okay, I'm going to test these particular subcharacteristics. You could have a checklist. So, for example, in Jakob Nielsen's book, I think it's called Usability Engineering, there's a chapter on heuristics for usability, and you can derive a checklist of things to look for from that chapter, which I have done. It's included in one of my courses. And then if you're, say, going through user interface and you're, you want to test the usability of your application, is that you go through and on each screen and each field you look at that checklist and say, how does this measure up with respect to that checklist? This can also be some logical set of test conditions that you've that you've come up with based on, say, the functionality of the application, and that you go through and check those off. Like, for example, with an e-commerce application, you might say, okay, well, things on our checklist is putting stuff in the cart, taking stuff out of the cart, checking out, abandoning the cart, international shipping, domestic shipping, those sort of things could be on your checklist. The key here is that this set of test conditions, the contents of this checklist, or whatever you're using, they don't change from one iteration to one release. This is what makes it substantially different than say, an analytical model. In an analytical model, remember, an analytical strategy, excuse me, in an analytical strategy, we start with more or less a clean slate and develop a set of test conditions based on our analysis. In a methodical strategy, we start with a predetermined set of conditions. Now, as was mentioned to me and came up during the presentation of this material at the STP conference in New Orleans last week, there's sort of a spectrum here between methodical and analytical, right? I mean, you could, in an analytical process, you could very well have some things that you're going to test that you test consistently from one release or iteration to the next, right? So there's a sort of a methodical element to the strategy, right? And it's also true that in a methodical test strategy, you might, at the beginning of each project, go through and maybe modify, add, delete, change some of the elements in your checklist. So those modifications could be based on an analysis of the current product and things that happened last time and so forth. So, you know, the more static the set of conditions is, the more the strategy is methodical. The more dynamic and changing the set of conditions is, the more the strategy is analytical. So that's a good way of kind of thinking of these. It's really sort of a multi-dimensional space being created here and by these strategies, and the extent that some of these strategies are kind of like different from each other in some way, and you lie somewhere along that spectrum. Now, so methodical characteristics, methodical strategies characteristics. Well, benefit is the testing is very consistent from one release to the next. It's very much, you know, the same kind of testing over and over again. So if you want consistency, you know, the methodical strategy is a good strategy to follow. Now, what are some factors that are necessary for the success of a methodical strategy? Well, obviously enough, the set of test conditions in your checklist or your standard or whatever it is that you're following has to be adequate. It has to cover the things that need to be covered in your application, and it needs to be current. It needs to be up to date. So that's one factor. Another factor is obviously enough the stable test object, right? The object has to be changing very little. When I say test object here, I mean system under test. There's going to be very minimal changes to it, because to the extent that it's changing, that's outdating the checklist. Now, the risks, obviously enough, is that your set of test conditions is insufficient or outdated. Outdated because the object of the system under test has changed too much since the time that the checklist was originally created. Now, in a methodical approach, there is still stakeholder involvement, but the stakeholder involvement is fairly minimal in the sense that it's only necessary in the initial definition of the test conditions in the checklist. Excuse me, another sip of tea there. Once the checklist is put together, it really doesn't need to change from one go to the next, and so there's really not a need to involve the stakeholders in that. Okay, the next set of strategies is what I would call process compliant test strategies, in a process compliant test strategy, you can tell that somebody's following one of those, and that they are following a set of processes that were defined by other people. They've seen somebody else's defined process, and they say, okay, we're going to do that. Now, the process, what is the process going to address? What things is the process going to say? Well, process will address things like the kind of documentation that should be gathered, the test basis to be used for deriving the tests, the test oracle, what we're going to refer to try to determine pass or fail status for the tests, and they might also address the way in which the test team is organized. Now, examples of process compliant test strategies would be things like Agile testing. So if you're following an Agile, your organization is following an Agile life cycle, then that has certain rules about things like the rapidity of change and things evolving and the duration of the iterations and the fact that the testers are supposed to be embedded or engaged directly in each sprint. They're part of the sprint teams or iteration teams. The estimation is done using a certain approaches such as what's the so-called planning poker. So that's an example of your process compliant test strategy. Now, what are some of the benefits of a process compliance strategy? Well, again, you're using a process that's created by others. So there is a certain amount of skill and experience that those other people had. I mean, otherwise, why would you select a standard or a process that was not not developed by people who are smart? I mean, it's not like you're going to go out and say, I want to find a process that was defined by the stupidest people on earth and follow that. No, nobody does that. So you're basically trying to take advantage of the what these people know. Now, this could be the IEEE 829 Standard Committee if you're following that process for documentation, or their new standard which addresses process as well, as I mentioned, Agile. Now, key factor for success here is that selected process needs to be aligned with your existing testing problems, your existing situation. If you're trying to follow Agile techniques and Agile testing techniques, but you're in a sequential lifecycle world, and that's not going to work out very well, and vice versa. So, make sure that the kind of problems that you're facing, the situation that you're in, is well aligned with the kind of problems that the originators of the standard were trying to deal with. Now, some risks that can affect process compliance strategies. One is improper understanding of the process. So you don't understand the process, and thus you're not able to carry it out successfully to some extent. Another risk is improper implementation of the process. Or there are organizations that understand things, and they say, no, we just don't want to do that. So an example of that is with Agile, which we see not infrequently, that organizations have sort of selected the parts of the process that they like, and yet thrown out parts that management or the individuals want to throw out, and then they're wondering why the process isn't working properly. I mean, one client where they were perfectly happy with the letting things change all the way up until the last minute, but the whole sustainable workload thing was something that they weren't prepared to commit to at all. So what would happen is that every 4 weeks, the test team had to work Saturday and Sunday because there was still development being done going on all the way up until Friday, and then stuff was getting tossed over the fence, as it were, to the testers to finish the testing over the weekend. So they were working massive amounts of overtime for this completely arbitrary reason, which is to try to hold to the sprint dates. And the reason that was happening to begin with was because of a breakdown in the estimation process and in the triage that was supposed to happen, and removing those excess features from the sprints. And then another risk that can occur is misapplication of the process. So applying the process in a situation where it's not a good fit. There are some things which enable the successful use of the process of a particular process, and other things that are disablers, if you will. And if you try to apply it in a situation where it's not going to fit, you're going to have problems. So, for example, following the very formal and documentation-heavy IEEE 829 standard in a situation where people are trying to be more lightweight from a documentation point of view is going to be an issue, and we've certainly seen this with some of our clients. So you got to understand, use the process in a place where it's going to fit. Now, the stakeholder involvement in process compliant strategies really depends a lot on the process. The Agile is, there's going to be daily interaction theoretically between the business and technical stakeholders and the testers. So other types of processes, the prescribed, if you will, stakeholder interaction might be periodic or episodic, happening only at particular points in time. For example, in a V model life cycle, there's the assumption that there's going to be verification and validation activities at the end of each phase. So requirements, design, and code, and you'd expect that the testers would interact with the stakeholders at those periodic assessment points. Okay, so next we come to the reactive testing strategies. Now, before I dive into this, I want to mention something. You might be sitting there thinking, okay, we've talked about a few test strategies, there's a few more to go. Where do these names come from? Well, pretty much I made them up. There was an email discussion that I had like years ago, about 10 years ago or so, when I was first really kind of formulating more clear thinking about strategies. I had this email discussion with Kim Kaner and Ross Collard and Kathy Iberly, I think, and there might have been one or two other people that were kind of involved in this. But based on that, and I'm going to take full blame / credit for this list. Based on that, I came up with this list. It certainly includes ideas that I got from them, but the names that are here are the names that I decided to hang on these particular patterns. So coming to reactive testing strategies, a reactive testing strategy is a strategy where the approach to testing is evolving very, very rapidly. And so, it's as the name suggests, we are reacting to events on the ground, as it were. The tests will be derived from people's actual experience. So you also hear reactive testing strategies. People talk about using experience-based test techniques. So if you're doing a lot of experience-based testing, in other words, testing that's based on what people know and about the system and the way it's built and what it's supposed to do, rather than formal models for testing like state transition diagrams and equivalence partitioning and those sort of things, then that's how you know that you're looking at something that's reactive. Another key element of a reactive test strategy is that the design and implementation of the tests only happens once the test item is received. We're given the system to test. Based on what we've been given, we derive our tests. And in fact, the tests continue to evolve, hence the reactivity, as we discover new and hopefully interesting things about the tests and how they, or the system, excuse me, and how it works. Now, some people say, well, that sounds pretty loose, and it certainly can be. Purely reactive strategy, many times people have some concerns about, well, how do I put this under control? How do I put some structure around it? So one way to do that is to use various things like defect taxonomies and what James Whitaker referred to as fault attacks in his book, How to Break Software. We can have some idea of or parameters around where we're going to explore in the system, and those structures can be put in place prior to us receiving the system under test. But the specific tests that we're going to run will have to be created at the time that we receive the test. That's what makes our strategy reactive. Now, the benefits of a reactive strategy are, one is that it tends to find a different set of defects than would be found via the other strategies. So it can be used in a complementary fashion to make sure that we're not missing those kinds of defects. Because of the documentation and other effort is very lightweight up front, type of overhead's very lightweight. It has a low cost per defect. Now, I want to be clear about this because somebody brought this up in New Orleans. They're like, well, you're saying it's necessarily lower cost overall. And I'm saying, well, no, that's not my point here. What I'm saying is because it tends to be very effective at finding defects, the cost per defect tends to be very low. So that's just to be entirely clear, that's the point I'm trying to make. if we look at the total effort expended on doing some kind of reactive or exploratory testing, add that up and divide it by the number of defects, your person hours per defect is likely to be very low relative to some of the other techniques. Primarily, it's because of the lack of upfront overhead. The testing is going to be continuously refocused on the system as it's actually being delivered. So the issue of shooting behind the target that can happen in some circumstances is less likely here, especially with rapidly changing products. And reactive testing is robust even if we have a very incomplete test basis. The requirements specification, design specification that's not there, or is very vague or missing a lot of pieces, it has very little effect on these reactive techniques. Now, some factors that are required for this to work. Number one factor is skilled and experienced testers. And this means people that not only are very good testers, but they have to understand the application and they have to understand the underlying technologies. That phrase experience-based testing, it really does sum up the essence of what's required for successful reactive test strategies. That you have to have people that are very experienced. When this is attempted with junior testers or testers who are brand new to a complex application or complex technology, then this tends to be very ineffective. Which brings us to the risks. So the number one risk is insufficient skill as a tester, or lack of knowledge about the system or the application problem space, if you will, the subject of the application. So, for example, if to use an example from one of my clients, they do oil exploration software, and they told me that they only hire people with experience as oil exploration engineers, if you will, people who actually do have experience looking for oil using various kinds of simulation software such as they build. The test manager explained it to me this way. He said, I can teach people all the technology that they need to know, and I can teach people the testing skills that they would need to have, but what I can't teach people in any realistic period of time is everything that they need to know about the oil industry and oil exploration to test this application. Now, another risk in reactive strategies is problem with demonstrating what was actually covered. I mean, it tends to, out of these reactive strategies, you get a big pile of bug reports, and you get them cheap, so people like that. But then the problem is that you turn around and go, okay, that's great from the point of view of the find defects objective of testing. Typical objective of testing is to find defects. But another typical objective of testing is to build confidence that the system works properly under certain conditions. Reactive testing does a very bad job of building confidence because it's very difficult to establish what has and hasn't been tested. Now, there are some fixes to that using things like test charters and so forth, where you start to put some structure in place. And, again, to the extent that those test structures, those test charters, are being put in place before the testing is being executed, you're moving on a spectrum now away from the reactive end of the scale and towards a more either methodical or analytical strategy, depending on whether the set of test charters is static or dynamic, respectively. So, there are ways that people address this issue, but by doing that, they're effectively becoming less reactive. Now, because reactive strategies are so different and tend to have a complementary set of strengths and weaknesses vis-a-vis methodical or analytical or even model-based strategies, these are often used in combination with the more formalized strategies, and that allows you to have coverage measurement, like when I was discussing analytical, And the same applies for methodical strategies, but also leveraging the knowledge of the testers. We typically recommend for our clients that they include reactive testing as part of their strategy, and that anywhere from 10 to 20% of the test execution effort should be using some sort of reactive technique. Now, next we get to the consultative test strategies. And this is basically, you're following a consultative test strategy when somebody else outside of the testing team tells the test team what to test. It could be multiple somebody else's, but it could just be one. And these external stakeholders or external stakeholder are completely in control of the conditions that will be covered. Now, this this sometimes perplexes people. Like, well, why would we do that? Where does that work? Well, that works in situations where the test team really doesn't have the insight that it needs to decide what to test. An example of this is, let's say that you're building a browser-based application of some kind or another, and you don't want to pay a lot of money to have a lot of different configurations available. Or let's suppose that you're building a mobile-based application, and you don't want to pay, as somebody said to me in Moscow last week, you don't want to have a cubic meter of handsets in the test lab that you're going to use to do all of your compatibility testing. So what you do is you go to a testing service provider that sells compatibility testing services, and presumably those people will have all of this hardware and all the software, and they'll know how to set it up, and they'll know how to do the testing of those different configurations, so you don't have to learn how to do that. And you just say, look, these are the configurations that I want you to test my application on. That completely specifies the conditions. And then you say, all right, go off and do that. We're going to give you the software, go off and do it. The testers are left to figure out what's the right way to test in those different configurations using techniques like equivalence partitioning and boundary value analysis, and maybe pairwise techniques if you've got some particularly high-risk conditions that you want to look at, and then come back and give you the results. So that's an example where the testing service provider is effectively following a consultative testing strategy, and it is fairly common in that particular space. Less common, and should be less common, in a situation where outside stakeholders are telling the test team, here's what you need to test. So following a purely consultative testing strategy when you're talking about an in-house test team, usually that's a sign of some degree of dysfunction. Now, what are some of the benefits of the consultative strategies? Well, to the consulted stakeholder or stakeholders, obviously, they're exactly what they wanted to get tested is going to be tested, right? So the testing is completely aligned with what they want. Now, that brings us to the factors for success. Obviously, for this to work, the consulted stakeholders must have a good idea about what is supposed to be tested. They need to be able to say the extent to which various things should be tested, and they should be able to tell you the order in which you want to be test those things. To the extent that any of those things are vague or wrong, that is what's to be tested, the extent to which things are to be tested, and what should be tested first, last, and everywhere in between, then the testing is going to be misaligned with the needs to some extent. Now, this brings us to the risks. There are a number of risks with a consultative strategy. One is when you got multiple stakeholders involved and they don't agree. You get kind of the test team is sort of whipsawed or caught in the middle of these conflicting expectations and priorities. The other, of course, obviously enough, is the possibility that the stakeholder is just wrong in terms of what they think needs to be tested. Like, so for example, if you're going back to this, building a mobile application, you select a particular set of devices that you think most of your customers are going to use, but it turns out that in fact, all of your customers are using another set of devices and not among that set that you picked, then your testing is just completely wrong. Of course, that's also could happen with testing of desktops configurations too. Like, you know, you think that most of your customers are going to use your application, browser-based application, using IE, but in fact that they're all using Chrome or Firefox. Then you tested the wrong things. Now, another risk is that there's not necessarily a way to check this. Kind of compounds the previous risk. Is, if you've got the set of browsers wrong and you're not doing something to check that, then it has no self-correcting mechanism within it. Now, if you were to include a reactive element to your strategy, and you tried some of the other browsers just to see what happens, and then you go, oh, look, there's a problem, then that can introduce a self-checking element, but you have to have a blended strategy for that. And of course, consulting the wrong set of stakeholders is going to result in problems too, because the consultative strategy, the ultimate source of whatever wisdom is inherent in it, or lack of wisdom, is the stakeholders that were consulted. Now, consultative strategies can be useful, as I gave you the example of the compatibility testing. So, you could be doing basically blending a consultative strategy with other strategies and trying to reduce gaps in your testing by doing that. Now, next we get to the regression-averse testing strategies. You're following a regression-averse test strategy when the main thing that you're worried about, your number one test condition that you want to cover, is regression. And one of the real common patterns that we see in organizations that are following a regression-averse test strategy is extensive use of automated test tools. Now, when I talk about automated test tools, I'm not just talking about automation of system testing. This can also be automation of, say, unit testing. So it's very common to see regression-averse test strategies included in Agile situations where, well, at least very common. It's not unusual, and it is certainly a best practice. You see people creating large collections of automated unit tests and feature verification tests using tools like JUnit and Fitness, respectively, and then integrating those into their continuous integration framework using something like Hudson, and then rerunning those tests on a daily basis, say every night, sometimes even more frequently than that, in an attempt to detect regression. And that makes a lot of sense if you're in an Agile world, because you're hammering on the code base, you're changing the code base a lot, and thus the risk of regression is very high relative to, say, a sequential life cycle model where the code tends to get stabilized and only modified to fix defects once you enter system testing. Now, some of the key characteristics of regression-averse strategies, starting with the benefits. Obviously, we want to minimize the risk of regression in key areas. That's what we're focused on. We'll also typically want to support quick releases of these new versions, and that's where the automation comes in. So being able to manage regression risk in a quick fashion is what you want from a regression-averse test strategy. Now, some of the factors for success in regression-averse strategies, well, obviously enough, successful and efficient automation at whatever level you're tackling the problem on is typically one of the things that you need to see here. That there's really no, even relatively simple applications tend to grow over time, and unless the application starts simple and remains simple, the attempt to do manual regression testing, even with a army of cheap test resources, tends to not work very well. Now, not only do we need the automation to be efficient, it also needs to be very maintainable, and this is where a lot of organizations get bit is they have problems with maintaining their automation. They build it, but it doesn't react well as the product continues to evolve, and they end up wasting a lot of time revising existing tests, which then leads us to the risks. If the tools are not sufficient to the job, they will not allow you to build a good set of automated tests, or the tools are just plain not available, then your automation effort is going to be difficult or impossible. If there are a large number of tests that you need to run that are essentially unautomatable, which basically means either that human judgment is required to interpret their results, or a human being has to be involved in running the test to keep them running, then that impairs your ability to automate. Trying to automate with people who don't have sufficient skills is another major risk. We see this with a number of our clients. A over-focus on regression leading to poor or insufficient testing of the new features is something else that we've seen with some of our clients following these strategies. And changing scope. The regression-averse the strategies are very, very conservative in the sense that in order to benefit from automation, you have to be able to say, here's a set of tests that's worth running not just 2 or 3 times, but 200 or 300 times. We're going to invest the effort to automate all those tests. If every day is a new day in your organization, and you can't say what you're going to need to test from one day to the next, then this is not going to work very well. Now, I mentioned the need to do this on Agile projects because of the change. And certainly, it's also other types of projects that's very important. And in the best case, this automation effort is collaborative between the developers and the testers, making sure that you've got a good testable architecture of the system, and the tests are going to be maintainable. To give a counterexample of this, we had a situation with one of our clients where the people were off developing the next generation of the application that's going to be used to manage the data center, and then like 6 months before they were going to go live, they told the test manager, "Oh yeah, you have this new application infrastructure architecture. It's going to be great. You'll love it. It's all browser based." And well, they had invested some 5 to 10 person years of effort developing a bunch of automated regression tests that all worked through their existing Windows-based, Microsoft Windows-based interface, and their tools were completely incompatible with the browser-based approach. And of course, the UI had completely changed too. So all of that investment had been completely wiped out by that lack of coordination between the developers and the testers. Now, those are the main strategies. There probably are 1 or 2 others lurking around there out in the wild world, but I would say that I've not seen them. These are the strategies that I've seen and have seen work. Now, an important thing to mention here: strategies are not religions. You don't have to believe in one of these things. You blend them. Okay. Now, this is going back to Sun Tzu and the Art of War. There's a section in the beginning of that book where he talks about different strategies of war, and what he does in each case is he says, okay, if this situation prevails, do this. Otherwise, if this situation prevails, do this other thing. So, you select a smart strategy. You can blend the strategies together based on the different benefits that you're trying to get. They're often very much complementary. And you can use the benefits to balance the risks. One strategy's benefits can help you mitigate the risks inherent with another strategy. So certainly the most successful test teams that we've worked with around the world are ones that are following blended strategies, where they select some set of these strategies and mix them together. Now, that can change from one project to the next, so you want to remember to be flexible. Don't just say, okay, here's our test strategy, and this is the 3-4 elements that is in it: reactive, analytical, model-based, and regression-averse, and we never change. We always do those. Now, that's not smart either, because that's basically got the same weaknesses as the methodical test strategy. in the sense that if your circumstances change, the particular set of strategies that you've selected might be suboptimal for that particular situation. So as Sun Tzu advised the generals who studied his book, be ready to evaluate the actual conditions on the ground and then formulate your strategy accordingly. Okay, so some quick conclusions here. There are a large number of strategies that are in common use. The ones I mentioned are all ones that are out there. As we've seen going through these, each has their strengths and weaknesses, so you have to understand, the real problem that you're trying to solve when you go to select a strategy. Picking the wrong strategy is a frequent cause of the test team failing because you're not aligned with the real problem being solved. You're not germane. You're not relevant if you're using the wrong strategies. We've seen situations where entire test teams are dissolved because the wrong strategy was used. Now, this, to be clear, you can do everything right in your testing, but if you're following the wrong strategy, it just doesn't matter. It's like you could be driving, you're following all the laws, you're making great time, you're avoiding traffic, but you're going the wrong way. So you're not going to get to your destination. So be sure to take this selection and blending process for the strategies very, very seriously. And do involve stakeholders. Your stakeholders, your technical and business stakeholders can help you better understand the actual problem that you need to be solving. Testing provides services to project stakeholders and understand what their needs are and proceed accordingly. And do blend the strategies. Do not fall into the quote-unquote schools of testing trap and say, oh, I have to follow one of these. I have to pick one of these things and stick with it because as much as that might be a good idea in some particular situation, it can be a really bad idea in a number of other situations. And in fact, I think almost any time you pick just one of these strategies rather than blending them together, you're going to be in a suboptimal situation. Okay, so as usual, I will put the advertisement up here and take questions from the audience. Before we get to the questions, I want to remind those of you with PMP certifications that this webinar does earn PDUs, and as I said, we are looking for additional volunteers to review the materials, so if you're interested, please send an email to info@rbcs-us.com with the subject line PMI PDU volunteer. Now, I'm afraid that we can afford to pay you exactly what we charge for these webinars, which is nothing because they're free, right? But we will thank you publicly anytime that you help us out, and do appreciate everybody's support. So to questions, let me undock the panel here. Let's kind of navigate this somewhat clunky UI that GoToWebinar has. Love GoToWebinar; it's a great product, but it's the question and answer interface a little tricky. Though I suppose if I had some kind of dual screen format, I could have the questions on one page and the slides on one screen and the slides on the other, and that would work pretty well. So first we got a question from Cindy. Cindy asks, could you repeat the PDU code? Sure. TSAW100. TSAW100, and our provider ID is 2986. Okay, Dwight, good to see you back. Dwight says, I think a requirements-based strategy could be combined with a risk-based strategy. Would you agree? Absolutely, and I think the best implementations of risk-based testing do include that. So one easy way to do that is after you've done your risk analysis or your risk identification, is go through the requirement specification and make sure there's at least one risk item that maps back to each requirement specification element. And better yet, capture that traceability. If you find a requirement specification element that doesn't have a corresponding risk item, then you've missed one, and add it. And then then you go through the process of assessing the likelihood and impact of those. You've now got a more complete set of items. And if you preserve the traceability between the requirements and the risks, you can use that to do things like produce good measurement of the results and tell people which requirements, the test results, tell people which requirements have the highest risk associated with them and thus are going to be most costly to test. And hey, maybe we really don't want to do that because the cost of testing it might not be worth the value of the feature and so forth. So definitely a good idea to blend those two strategies. Now, Tom, it's a similar question. With risk-based testing, wouldn't you ideally need to have a requirements doc to help facilitate the risk discussion? Well, Tom, I actually prefer not to do it that way. I prefer to do exactly what I just described, which is to do the risk identification purely as a brainstorming exercise without reference to any document. And then after the risk identification process is done, then go back and go through the requirements and see if anything's missing. The reason for this is that if you constrain your thinking to just what's in the requirements, your risk analysis will have the same weaknesses that requirements-based testing is, which is to say that if it's not in the requirements, it won't get tested, and if it's wrong in the requirements, it gets tested wrong. To the extent that we can avoid that by doing risk-based testing, reintroducing the sort of requirements-based parameters around the risk analysis simply limits one of the benefits that we can get from doing risk-based testing to begin with. Now, I realize that there's been a lot of sand thrown in the air on this, if you will, kind of clouding up the subject, because one description of something which is referred to as risk-based testing talks about doing exactly that, of going through and identifying test conditions through an analysis of the requirements, and then putting risk assessment, likelihood and impact of failure on each of those conditions. To me, that is not risk-based testing. That is basically risk-weighted requirements-based testing, because ultimately what the tests are based on are the requirements rather than the stakeholders' general understanding of the risks. Somebody asked, Bradley, who apparently has left, said, I missed the beginning of the webinar. Is it being recorded, and will it be sent out after the webinar is over? Yes, the webinars are recorded. They are on the digital library page. If you go there, you'll be able to find them. They generally get posted within about 2 to 3 days of the webinar itself. Remember, though, if you're a PMI, PMP, and you're trying to get PDUs, you can't do that by listening to the recorded webinars. If they catch you in an audit, and we just had someone come to us saying they were being audited, there will be some sort of consequences for that, and probably not good. Okay, so Rich asked an interesting question here. This is something that came up in the session at New Orleans, and he says, when I saw today's topic, test strategies from around the world, I viewed this from a cultural and generational view. So a summary question: do Asia-Pacific teams, for example, apply methodical strategies differently than Latin Americans, or similarly, will millennial testers approach model-based strategies different from pre-baby boomers? That's a great question, Rich. I'm glad you asked it. And I would have to say no, there doesn't seem to be a correlation between where you are and what strategies you're following. Nor does there seem to be much of a correlation between how old you are and what strategies you're following. Now, in the last case, age and strategies, let me just qualify that a little bit. Certainly, when you have very young testers who are being managed or led by similarly inexperienced leads, there's often really very little, if any, strategy at all. And it tends to just sort of, well, what tends to happen is you fall into, the organization falls into one of these patterns, but there's certainly no deliberate choice about which of the strategies is being followed. So, but outside of that, there really doesn't seem to be cultural or generational aspects to this that occurs to me. Now, there can be business-related patterns here. So, for example, a lot of outsourced testing is done, say, in countries like India and Malaysia and China, and in the case where there's a lot of testing service providers, there's going to be a disproportionate amount of consultative testing strategies being followed. But that's not based on any cultural preference. That's just based on the business considerations. So I'm glad you brought that up, Rich. It is an interesting question, and you know, one that I will continue to keep my eyes open for. But to this point, I have not seen any such patterns. Tom asks, can't I follow a methodical strategy using checklists and quality standards even when I choose to follow a risk-based approach? I don't see how methodical is a strategy. It just seems to be a set of tools to support any strategy. Well, a methodical testing strategy, what makes a testing strategy more methodical is the extent to which we do, from one release to the next, we test the same conditions that we tested before. So it's not even following the same process, because we can be conservative from the point of view of following the same process from one release to the next, and even following the same strategies from one release to the next. Set of test conditions that we come up with might be very different. But in methodical strategies, the test conditions are the same from one release to the next. Now, to your point, I mean, could we have done a risk-based approach and generated the set of test conditions and then used those test conditions over and over again from one iteration to the next and from one release to the next? Sure, in that case you have sort of a blended risk-based methodical approach, though you're losing one of the key benefits of a true analytical risk-based strategy, which is that analysis at the beginning of each release or iteration allows you to realign the testing with the true risks to the quality of the system. So Tony asks, are these really individual strategies, or are they elements of a single strategy? That is, a strategy may have a mix of analytical, model, methodical, etc. Yes, absolutely, Tony. As I mentioned at the end, you know, I think it would be extremely unwise to just pick one of these things and say, I'm always going to do this. I'm always going to be purely analytical, risk-based. I'm not going to test anything that doesn't follow directly from an analysis of the risks. You want to blend these. So these are like elements of a strategy, and then the successful strategies are an amalgam of the most appropriate elements in a given situation. So Tom says, wow, I'm lost. How is it that testing on an Agile team makes it a process compliant strategy? Doesn't every software team and SDLC end up with some degree of process and process compliance? Okay, so yes, it's a fair point to say that if a test team is to be successful, part of its strategy, one of the elements of its strategy, or some of the elements of its strategy, must be considering how to accommodate the natural attributes of that testing, of that SDLC, how testing can successfully deal with those attributes. That's definitely an important consideration. Now, do we see examples where people are totally tone deaf and not considering the SDLC? Absolutely, but usually that's a very short-lived situation, because either people figure out that that's a bad idea, or they, as the euphemism goes, are invited to pursue other career options. Now, we also see the opposite mistake, which is that the only thing that is going on is process compliance strategy. You know, and you get into this in situations where you hear what I call the three-letter firing squad, which is a three-word firing squad. That's not Agile, and these organizations that have adopted a very dogmatic approach to their implementation of Agile, and anything that's outside the sphere of what's considered to be, Agile methodologies and Agile approaches is summarily executed, and no consideration of it is possible. So if you're in a situation where you're contemplating how to include a risk analysis, for example, as part of a sprint, and somebody says, "Oh no, we can't do that. That's not Agile." Well, okay, I would say that being dogmatic is actually not very Agile either. And in fact, a number of our clients do include risk analyses as part of their planning process in their iterations. Yes, you've got to take that into account. Gary says, "Saludos, Rex." Saludos, Gary. And Gary, my co-author on the Fundamentos de Pruebas de Software. Okay, Tom's got another point here. Maybe not a question. Key thing I'm getting is that these are patterns often seen when viewing test teams in action. I'm concerned these are not really strategies. Wouldn't a strategy be more like using a proper mix of risk-based and model-based and reactive techniques as appropriate to meet project goals? Well, I guess if you call them what you want, Tom. I mean, if you want to call them patterns and you want to call the actual implementation of the appropriate mix of those patterns a strategy, I'm fine with that. I'm sort of following the ISTQB terminology here, where strategy is a project-independent way in which the testing is going to be done, and the approach is the specific implementation of that strategy on a particular project. But again, I'm not huge on names. If you find it more satisfying intellectually to call these patterns and to call strategy that thing which you create by blending them, that's cool. Another thing you could call these is like elements or dimensions, and where you pick a point in a multi-dimensional space based on these different dimensions. That's fine. I think that's another way of thinking about it too. Whatever mental model allows you to conceptualize your different options here and how to be successful with them, I think is great. Let's see. Diane says, these sound very similar to the ISTQB approaches. How are they different or the same? Well, yeah, they are, because as those of you who've been through the ISTQB program might have realized or might remember, is that that list of strategies that's in the foundation syllabus and also in the advanced syllabus and now in the expert test manager syllabus is derived from that same list that I assembled based on my conversation with Kem Kaner and Ross Collard and Kathy Iberly and, as I said, a few other people. Carlos asks, do we have access to the slides? Yes, you have access to the PDF version of the slides right now. It is on the basic library. Go to rbcs-us.com, select the resources tab, upper middle, and then a drop-down menu will come down, navigate to the library selection, and then the basic library selection. Go to the very bottom and you'll find them. The recorded version of the webinar will be posted in the next few days on the digital library page, which again, it's on the resources tab, and you navigate to the library and then the digital library, and you'll find them. Okay, Tom's got a good question here. Are consultative and risk-based strategies similar? Both require stakeholder input and direction. Just trying to understand the difference. Yeah. So in a risk-based strategy, the test manager or lead test engineer will interview the various technical and business stakeholders or hold a brainstorming session with those stakeholders, identify the risk items, and then assess the likelihood and impact associated with them. So in a consultative approach, or a consultative strategy, the 1, 2, maybe 3 stakeholders go to the test lead or test manager and say, this is what you're going to test. So those are somewhat similar in the sense that the stakeholders are playing a key role, but the difference is that the in a risk-based, and really any analytical approach, especially risk-based, analytical risk-based testing, the test lead or test manager is much more guiding and shaping the list of risk items that are ultimately derived, because you're going through a facilitated brainstorming session. You're facilitating as a tester, and you're basically helping people reach a set of conclusions about what the risk items are. For example, you're going through a particular list of risk items, or risk categories, excuse me, that you have found useful on previous projects. So, you know, again, there's sort of this dimensionality aspect here, the ends of the spectrum, right? You could say that, you know, to the extent that the test lead or test manager is really guiding or facilitating the process of identifying the test conditions, then we're kind of more risk-based. To the extent that the stakeholders are really dictating and the test manager making very few choices and exhibiting very little influence over that process, it's more consultative. Let's see. Cease got a question here. Hi Rex, I'm a reactive tester in Agile processes, generating loads of defects to despair of stakeholders. Test oracles are rare because the behavior is unclear and the stakeholder is reluctant to solve the defects. How to solve this dilemma? As a tester, I get frustrated when defects don't get solved. In terms of Agile reporting, defects then turns into waste. So there's a couple things that I'd like to address here. One is, you know, this testers getting frustrated when their defects don't get fixed. I think you really need to learn to disengage from that, not get ego involved in quote unquote your defects, your bugs, right? We're sources of information as testers, and that's I think really the best way to think of our job. Now, standing back, you know, if you're coming into a situation where you're finding a ton of defects and they're not getting fixed, and you know, there's a big backlog that's building up, well, that sounds like there's something broken in your organization's implementation of Agile, because the best practice that we've encountered is what's called the fix bugs first approach to Agile, which is to say that, you know, you try to fix every bug that's found in a given iteration in that iteration. But if there are bugs that survive to the next iteration, then that should be the first thing done in that next iteration. You're not accumulating a lot of defect backlog. Now, that of course could be, there could be another angle here, another issue, which is perhaps what you're calling defects aren't actually defects, right? You mentioned this issue where there's really not a good reliable test oracle, so you can't say what is pass and what is fail. And that obviously is a very potentially frustrating situation. And again, you know, this could indicate some problems with the Agile implementation that you're working under, because you know, there's supposed to be user stories as a term that's frequently heard, and these user stories should be adequate to help us understand what it is that should happen when we test something. Let's see. We've got another question from Tom here. Isn't the blending of these patterns the real art and craft of test management and test design? Well, yeah, absolutely, Tom. You know, to me, you can recognize a real expert test manager, somebody who's truly mastered the whole concept of what it means to properly manage testing and to provide good testing services, by somebody who is really wise and deliberate in the way that they approach coming up with exactly the right blended test strategy. And you know, conversely, you can recognize that people are still really struggling with what test management is all about by the fact that they don't have a slightest idea of what strategy they're following. They're just doing stuff, and they're sort of just bumping around, trying to do something that they think is right or that somebody else has told them is right. Now, Mika asks a question here. What are your recommendations of how and in which level to document test strategy and how to communicate that to others? Well, you know, any sort of document, any kind of form of written communication it's got to be, it's got to serve the needs of the audience, right? So who are you communicating to with a test strategy? Well, typically you're communicating to a couple audiences, right? You're communicating to the testers, because it's again going to be a general kind of description of how the testing is to be carried out, general and project independent. So you need to talk to the testers, for example, about, so, if we're following an analytical risk-based testing strategy, who are the stakeholders and how do we get them involved? And, what are the best practices for setting up brainstorming sessions or interviews and those sort of things. But another audience is, the people outside of testing who need to understand at a high level what your strategy is and how it benefits them and how they need to be involved. So it probably makes sense to have a couple sections to the document, and this first section being one that gives that kind of overview for the stakeholders and says, this is our strategy, and this is the benefits that it offers you, and this is what we need from you to make it work. And then it gets into the actual details. Veronica asked, for an application that changes each iteration, which set of strategies would you suggest? Well, obviously, if there's a dramatic amount of change from one iteration to the next, you want to avoid a methodical strategy because that's going to be problematic. Also, when you've got a lot of code change happening, you've got a lot of regression risk, but you do need to be cognizant of and aware of the change is potentially invalidating or breaking your regression test. So it's important that the test be designed and the automation be implemented, in such a way that it's not going to be strongly impacted by these changes. A lot of times the way that people do that is they choose to focus most of the automation on the API levels and use tools like the unit, JUnit, CPP unit, etc. types of tools and tools like fitness. Heidi asks, what have you found to be the drawbacks of blending strategies? Does it make sense to have timed changes from one strategy to another? Well, I haven't really found any drawbacks to blending strategies that are specific to the blending of them, because you're trying to blend them in a way as to optimize to get the best possible outcome. So to the extent that you're doing that well, there really aren't any drawbacks. Now, of course, like any other intellectually challenging task, you can get it wrong, and then that's obviously going to have drawbacks. But that's just the general drawback that apply of using the wrong strategy or wrong set of strategies in a given situation. Now, your question about timed changes, certainly yes. I think you should periodically reevaluate your strategy, and that should happen. Like I say, you've got a strategy document written down, and I would say going through that every 3 to 6 months and saying is this really what we need to be doing, and would make sense. Also, of course, I think it's a good idea, topic for a whole different discussion, but it's a good idea to have process metrics that are measuring how effectively you're carrying out your job, how efficiently you're carrying out your job, the degree to which you're satisfying your stakeholders through it, and you're measuring those through surveys. So we should have some sort of ongoing set of process metrics that we're evaluating that are telling us whether or not our strategy is actually succeeding. It should be more than just, well, we're happy with the strategy, therefore the strategy is good. So we as testers could be happy with the strategy, but doesn't necessarily mean that it's doing the right things. Well, once again, I'm proud to say that you guys have gotten so engaged in this presentation that you've asked me more questions than I can answer in our allotted time. So for those of you whose questions I did not get to, what I'd like to offer to you is that you take your question and send it to me. Send it to info@rbcs-us.com and use the subject line webinar follow-up question. And I will work my way through those questions over the next few days and try to answer as many of them as I possibly can on the blog. which is rbcs-us.com/blog. And then you'll get an answer there in public, and you'll know via email that when I've gotten a chance to answer your question. I do greatly appreciate all the participation and the questions. So to close this session down, a little bit more about resources. Many of you will be familiar with the fact that we run these webinars once a month. So if you check our website, rbcs-us.com, you can sign up. If you want a special webinar presentation for your company of this webinar or any other topic related to software testing, send an email to info@rbcs-us.com or contact us via our website. You can sign up for our free newsletter at rbcs-us.com. This gets you discounts on our consulting and training services and a regular newsletter that has a featured article on software testing and quality and news about what RBCS and its partners are up to. We're on Twitter at twitter.com/RBCS, and we're at Facebook, facebook.com pages RBCS-INC. Check your email over the next couple days. You might be the lucky winner of a free e-learning course. You were registered just by attending. As I said, check out my blog. You can comment on anything that's out there currently, or if you want to discuss something with me on the blog, send an email to info@rbcs-us.com with the subject line blog topic, and we'll try to pick it up there. Check out the digital library. You've got recordings of these webinars along with podcasts and videos available for free there. Everything on the website that's not in the store is free. You can subscribe to our podcast via iTunes and our RBCS podcast into the search string, and you can see videos and recorded webinars on the RBCS channel on YouTube. We offer these free resources as a service to you, the software testing community, because we are a not just for profit company. That concludes the webinar. Thanks everyone for joining us today. I look forward to seeing you again on future webinars.